Hey guys, today we worked on parts of a graph and we practiced graphing our data from our airplane investigation. So a couple of things I want to point out to you and let you remember. When you're looking at your Google Classroom, if it's a Google Classroom assignment, it's got a little reminder here to tell you when things are due. Notice I've got A and B day on here, so it looks a little different. And on yours, because you have the student version, down here instead of this file folder, you'll have like a little person inside of a box. You can click on that to see, it'll say view your work. So you can see if you have done everything you're supposed to, if you turned it in, if you marked it complete. Okay, so just remember that that's there to help you out. But for today's stuff, I'm gonna go to Classroom, and it's already there for me, but in the Science Notebook topic, we added some things in. Okay, the nice thing about the video, just pause it and write them in your Science Notebook. Okay, we added a couple things in. If I scroll down, you'll see that I added, well, that was my data chart from the other day. That should be totally filled in. I did 3 trials for each of my planes. I totaled up the distance it traveled and divided by 3 to get the average. Okay, and we're going to be graphing the average for plane 1 and plane 2. So make sure this is completely done before you try to start doing your graph. But we also have our parts of a graph notes. Okay, so this is on your Google Classroom, so you can make it bigger. You've done graphs in math class. We're just reviewing that and showing you how we put math to work. You've got your y-axis, that's where your dependent variable goes. Your x-axis, that's where the independent variable goes. And to help you to remember which is which, just remember dry mix. Okay, so quick little easy word phrase to remember. Think like cake mix or brownie mix. It's in the box before you make it. So dependence, also known as responding, and we find that on the y-axis. Manipulated is also known as independent, and we find that on the x-axis. And a lot of you kind of naturally put those in the right place just from past experience, but we need to know that that's for sure where they go and why. Okay. A couple other things that we pointed out is that you should have a label on the x-axis that's clear and a unit if appropriate, as well as on the y-axis. So whatever it is that you're putting on your graph needs to be clearly labeled so whoever looks at your graph understands, and have the appropriate unit of measurement for your graph. And a way just to make sure you've got your graph looking the way it should to communicate clearly, remember the word sultan. So think like Jasmine's dad in Aladdin. Okay, it's kind of like a king. But remember the word sultan, and you have each of the things here that your graph should have. Okay, so it's not necessarily in this order, but all of these things. Okay, notice you've got a title. Okay, it needs to be clear. It just can't be graph. Well, what kind of graph is it? What are we showing? I couldn't just put airplane investigation because I still don't know what my graph is about if that's all it says. Okay, so we already talked about labels on each of the axes, units with those labels if they're appropriate. Yeah, obviously your graph needs to be neat because if it's messy, no one can read it. And the whole point of a graph is to convey information. And then obviously your graph needs to be accurate. It means you need to be very careful in plotting your points and drawing your lines so that it represents true facts. But probably the most important part is your scale. Okay, that's what's going to take the most brain power for you to do. So you have to figure out how much is each of these little grid lines. I know it's notebook paper, but imagine it was graphic paper. How much each little line is worth. Okay, so sometimes they'll refer to that as the scale. You might also see it referred to as the interval. Okay, so we put these graphs in to be able to come back and reference and have ourselves a checklist to make sure we're doing it right. So we're going to practice that a little bit by making a graph for our airplane investigation we did. Okay, so notice we were very careful to make nice, even, straight lines. So I put in my x and y axis. Started at 0. We're in quadrant 1, like you learned about in math class. Our plane never went backwards, so we don't have a negative number. We'll be constructing a bar graph because this is just conveying information. It's not change over time or anything. So we had 2 planes, plane 1 and plane 2. I've only constructed the bar for plane 1 just to give you an idea of what it kind of should look like. But notice I've got a title, and I'm clear about it. It's the design versus the distance. It doesn't just say airplane. Okay. On the x-axis, that's where our independent variable goes. That was our design. And remember, we've got our variables already picked out for us on our investigation page. So we already know what they are. We just have to put it on our graph. So plane 1 and plane 2, and if they had a particular name for the design, like Bumble or Dart or Stealth, put that there as well. And maybe my second plane, I made it up all by myself. So I put my creation. So that's clear, nice and spaced. The part, like I said, that you're going to have to give it some good consideration is here with the scale on the y-axis, because you don't really have a scale with airplane designs. It's just an object. But here, the trick that I showed everyone, what I like to do is look at my data chart, find my biggest number. So if I click back over here, remember I'm just looking at the averages. Okay, so with those two averages, find your largest number. Your graph needs to go just past that number. Okay, your graph should take up the majority of your page. So I know myself and I'll get distracted. So what I do, you can see I've made a little hash mark every 5th line, right? And then I go back in, I just count 5, 10, 15, 20, 25. So I have 25 grid marks to work with. So I need to figure out how much each little line is going to be worth. Okay. And for this particular piece of data, I think I used the kids' data, it was like 167. Okay, so I let it go all the way up to 200. I didn't necessarily need to go that far, but it gave me a good scale that was easy to work with. But you look at that biggest number, and then you divide by the number of lines you had. So I had 25. So I take the big number, like 200, and divide by the number of lines I have. And I can figure out how much each line is worth. So this particular set of data, which yours will be different just depending on your design and your average data, ended up to where on my big interval lines, it was like 50, 100, 150. You know, yours will be different. It doesn't have to look just like this. Okay, so we marked it off, and then just to make a nice, good-looking bar graph, my pro tip there was to use my ruler. All I did was trace the ruler. Like I marked off where the bar should stop, and then I traced the ruler there and colored it in. Okay, don't leave it just pencil. It's really hard to see. And of course, you need to do your second plane. Okay, so once you've done that, you're going to go into, everybody's emailing me, and then you're going to go into this week's work. Okay, so our thing for today was the airplane investigation. And you've got a copy of this Google slide, and you're going to insert your information. Okay, so when it decides to load, come on now. Okay. So on the first, I obviously put your name, but on the first slide, it's telling you to put a picture of your airplanes. Now, in case you don't have yours anymore, you can remake them if you want to, or go on like the website I gave you or the YouTube video and take a snippet of the picture and put it here. Or you can tell me the design name, like if you use the Dart or the Bumble or the Stealth, tell me that and just describe it a little bit. Okay, so if I forgot to tell you, oops, to keep your plane, that might be easier for you to do. Then your airplane distance data graph table. It's already in your science notebook. We filled it in last time we had class. Take a picture of it and put it here. If you're on a Chromebook and down in the little kind of gray search bar, just type camera. Okay, you need to get comfortable with taking pictures and inserting them into Google Slides. So that's one way to do it. Or if you have like a tablet or a phone, that's pretty easy too, and just save them to your drive, and then they're easy to upload. But we need a picture of your data table there. And then when you're done with the graph that I just explained, take a picture of it and input it here. Okay. And then you've got a couple quick conclusion questions. When we do a lab investigation, we'll kind of focus in on different parts of like the scientific lab write-up. So we don't have to do it all every single time, and we can learn on different pieces. But here, just a couple little conclusion questions. Now, there's a time and place for being short and sweet, but the conclusion is not it. This is like if you're writing something for English, you know, complete full sentences with complete thoughts, good grammar, good punctuation. But tell me which plane went further, and then explain why. Did you do a better job folding? Was it a more aerodynamic design? Like what made the difference? For the I learned, this could be any number of things. It's kind of wide open. Maybe you learned about how technique is important when you're constructing something. Maybe you learn that it's important to have an area that's clear with no obstacles when you're trying to measure how far your plane went. And then I can improve this investigation by. So scientists just don't get data and go, oh, I'm done. What can we do differently in the future? What can we change to make it better? What can we do in a different investigation um, to fine tune the answer I'm looking for? So here, this could be multiple things. Maybe you want to put something like use a different kind of paper or research different designs, like have more designs or change them by some people wanted to put paper clips or tape a coin to it, change the weight of the plane. Okay, so lots of room for personal creativity in this one. Right? And these should be done the next time I see you. So double check that you've completed everything and then turn it in on Classroom. Okay. Also just double check, go in and double check that everything is either turned in or marked as done. And as always, if you've got questions, feel free to come to tutoring. All right, let me know. Have a good day.